All right, welcome back to Robbie's Office Hours. So in these examples, we're trying to take something that's written out in expanded summation form, and we're trying to write it in sigma notation. Now I would argue this is pretty difficult because, well, these ones, there's not a unique way to do it, as I'll show you, okay? But the key with any of these is to try and find patterns, okay? So if I look at this first one, I have 5 divided by 6, okay? 5 divided by 6 plus 6 over 7, 7 over 8, 8 over 9, 9 over 10, 10 over 11. We kind of notice the numerator is just changing by 1 each time. 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. And so is the denominator, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11. And I notice that the denominator is always 1 larger than the numerator. So one thing that I could do is I could say, well, if I want to write this in sigma notation, what makes this difficult is that you get to choose where you start. If you say, I want to start with k is equal to 0, that's fine. If you want to start with k is equal to 17, that's also fine. It doesn't matter, okay? You just have to be consistent. So for me, what I'm going to do is I'm going to recognize that the numerator and the denominator are just 1 apart from each other. So if I let this be something like k divided by k plus 1, okay? That's kind of the right feel to it, right? Like the numerator's a 5, the denominator's 1 larger. The numerator's a 6, the denominator's 1 larger. So whatever the numerator is k, the denominator is 1 larger. Okay, so let's just see if this works. And then I have to say, okay, well, where does k start and where does k end? Well, the first term I need is k to start with a 5, and since k is the numerator, I'm going to say k starts at 5. Okay, k starts at 5. And then I need to say, well, where's it going to end? Well, if k is 5, 6, 7, 8, 9, 10, then that would suggest that k is stopping at k is equal to 10. Okay? So this would be completely fine, and then what you always want to do is just check it, just spot check it. So if k is 5, I get 5 divided by 6, good. If k is 6, I get 6 divided by 7. If k is, say, 9, I get 9 over 10. Okay, so I'm going to gather all of my terms. Okay? When k is the last one, 10, I get 10 over 11. But what if instead I had wanted k to start from 1? Okay, well this is the notion of re-indexing. Okay, so this is re-indexing. Now, what does that mean? It literally means you're writing the same sum, you're just going to start at a different place, okay? So let's suppose I want to write this sum by saying I want to start it where k is equal to 1, okay? So I want this bottom thing down here to say k equals 1. The way that you do it is you say, what would I need to substitute in right there for that k in order to make this k is equal to 1, okay? And I contend that if you replace k with k plus 4, that would do it, okay? Why is that the case? Well, if I plug in k plus 4 here, I get k plus 4 equals 5. I move the 4 over and I get k is equal to 1, and that's exactly what I want to do, okay? So I'm going to replace all of the k's with k plus 4. The one thing you have to be very careful about, though, is very rarely do you see sigma notation where they actually say k equals 10 at the top. It's typically just the number, but technically you should have a k equals 10 at the top, right? Because it's saying k goes from 5 up to k equals 10. So if you keep that in mind and you say, okay, well, if I want to re-index, I'm just going to replace all the k's with k plus 4s, what is that going to do? I'm going to get k plus 4 equals 5 up to k plus 4 equals 10, okay? And then I have to replace these k's as well, so that's going to be k plus 4 over k plus 4 plus 1, okay? And then we just do the arithmetic and figure out what's actually going to happen. So I'm going to erase this real quick so I have some room, okay? So do the arithmetic. K plus 4 equals 5, move the 4 over to get k equals 1, okay? K plus 4 equals 10, move the 4 over to get k is 6. And then this is k plus 4 over k plus 5. Okay? Now again, whenever you claim that this is the right thing, you should spot check it to see what's actually happening. So if k is 1, I get 1 plus 4, that's 5, over 1 plus 5, that's 6. So I get 5 over 6. Bingo. I got my first term. If I go to the very last one, k is equal to 6, I'm going to get 6 plus 4, that's 10, over 6 plus 5, that's 11, 10 over 11, boom. I get my last term. Okay? So these two sums, even though they look vastly different, they're literally saying the same thing. It's just this summation here. Okay, so just be aware of that. Sigma notation is not unique. If they had fixed like k is equal to 1, then that helps a little bit because then I don't kind of have the ambiguity of saying where do I start. But at the end of the day, it's not going to be unique. Okay, So then let's look at the second one. So I have to kind of look at the pattern. The first thing I notice is that the signs are alternating, okay? The fact that I have an alternating sign is telling me this is probably going to have a -1 to some power, okay, associated to that. And then I notice that this term is 1 squared, this is 2 squared, 3 squared, 4 squared, and 5 squared. So that kind of suggests that I'm probably going to have a k squared in that case. And now I need to figure out where k goes. So k is going to go, I've got to have k starting at 1. So that's going to be k is equal to 1. And it's got to go all the way up to, let's see, I forgot the 6 squared, sorry. So that's a 6 squared. And it goes 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, up to 6 squared. So it's going to go all the way up to 6. Now, I have to figure out what is the exponent on my -1. So I need it to start with a positive. So that means that, well, I can't just put a k here. Because think about it, if k is 1 and I plug in 1, I get -1 to the 1. That's negative, and that's going to give me a -1. So you could do this by saying k minus 1, for example. That would work. Because if k is equal to 1, I get 1 minus 1 is 0. -1 to the 0 is +1. I could also put k plus 1. Doesn't matter. Still going to give me the same thing. But that would be a version of sigma notation for this particular sum. Okay? Now let's look at this next one. Let's see if we can try and find a pattern with this. So I notice again I have alternating signs. So negative, positive, positive, negative. All that. Let's see, I have 4, 5, 6, 7, 8, 9. Okay, so that's just going up by 1s. And I have kind of like x to the 0, x to the 1, x to the 2, x to the 3, x to the 4, x to the 5. So those are kind of the things that are going to inform how to write this in sigma notation. So the first thing is I know is that I have an alternating sign. Okay, so I'm going to put a -1 to the something. We'll figure out what that something is in a second. Okay, I know that wherever k starts, -1 to that power has to be +1. Okay, so I know that much. I have 4, 5, 6, 7, 8, 9. So that kind of suggests like if I just put this as k, for example, if I just put that as k, then I would want k to start from 4 and then go up to 9. So I would say k equals 4 up to 9. Okay, but I haven't accounted for the x's yet, so that's going to be x raised to some power. Okay, I don't know what that power is yet. So that's kind of my start. And now I kind of have to diagnose and say, well, what do I need to actually get this to work? Well, I'm starting with k is equal to 4, which is even. So if I just leave that as -1 to the k, that would give me -1 to the 4th power, which is just 1. So that would give me a positive. If k is 5, -1 to the 5 is negative, so that's negative. Okay, so that negative sign is looking good. The k is looking good, but now I need to get the right power of x. So when k is 4, I need this to be like x to the 0. So if I put this as k minus 4, okay, then when I plug in k is equal to 4, I get 4 minus 4 is 0, x to the 0 is 1, so that's going to give me just 4. If k is 5, x to the 5 minus 4 is 1, so that's just x, so that's giving me that. And so this seems to be the right thing. Let's check the last term. When k is 9, -1 to the 9, 9 is odd, so -1 to the odd is -1, so that's negative. K is 9, so 9. X to the 9 minus 4 is x to the 5th. Okay? So here are some examples on taking expanded sums and writing them in sigma notation. If you like the video, comment down below, like, subscribe, all the good things, and we'll keep it going.